All right. So we've been working on this is support for chapter 4. It's on graphing. And we've been working with the slope, which is the change in y over the change in x. You might know it as rise over run. And if you have 2 points, it's y2 minus y1 over x2 minus x1. And we showed last time it doesn't matter which 2 point or what order you do the points in. Doesn't matter which point you label as point 1 or 2. As long as you're consistent. The homework will ask you something related to the following sentence, though, very specifically. The slope is the rate of increase of y for every 1 unit increase in x. So if x goes up by 1, y goes up by m. Give you guys a little bit more practice in this. Find the slope. If you are given the points 4, 2, and 2, -6. That looks like shit. There we go. And I'll bring that equation down so you can see it again. Alright, so. Which point should I label 1 and which one should I label 2? This will be point 1, okay. So point 1 goes on the right side and the y value goes on top, so the 2 goes up here and the 4 goes down there. And point 2 goes on the left side, -6 goes on top, and 2 goes on bottom, yeah. So -6 minus 2 is -8. 2 minus 4 is -2. And that reduces to 4. So this means that for every increase in x by 1, y increases by 4. As a reminder, there's a couple ways to do graphing. If you have ax plus by equals c, to graph, we can option 1, make a table, picking numbers. This is the slowest approach. Option 2, using the intercepts, which is similar to making a table. So you pick x equals 0 and find y, and then pick y equals 0 and find x. And when x equals 0, that's your y-intercept, and when y equals 0, that's your x-intercept. Option 3 is solve for y. And use the y-intercept b as a starting point. And use m for direction. So we'll give an example doing both. Table, we're not gonna do the table. Table's obvious. Let's do 3x plus 6y equals 18. So doing the two intercept methods. When x equals 0, that equation becomes 6y equals 18. Because 3 times 0 is 0. And we divide by 6 and we get y equals 3. So we will have a coordinate 0, 3. Do the same thing for y. When y equals 0, 6y becomes 0 and we're left with 3x equals 18. Divide by 3 and we get x equals 6. What? I am picking 0. If you pick 0 for these two, it's got to be 0 somewhere. Unless it doesn't cross the x-axis, it's got to be 0 somewhere. So I'm just plugging in 0 because it's easy to find, easy to calculate. There's less work. If I plug in 0 here, finding y is easy. All I gotta do is divide. I mean, when we do a table, if I plug in like x equals 1, then I got more work I gotta do. I gotta subtract. It takes longer. No. It's when y equals 0, 6 is x equals 6, so it's 6, 0, 0, 3. The 6, 3 doesn't, 6, 3 actually doesn't solve the equation. Watch this. So not 6, 3. That's an excellent question. If I try plugging in 6, 3 in there, 3 times 6 plus 6 times 3, does that equal 18? Eighteen plus 18 equals 36, which is not 18. 6, 3 is not on the line. A lot of students do this, Michaela. You're not the only one that's wanting to do 6, 3. Just because the number equals 0, we're saying it equals 0, doesn't mean that's not valid. 0 is a common fucking value for my wallet balance. I'll tell you that right now. My wallet frequently has no money in it. 0 is useful for a lot of things. 0 is the number of fucks I give about a lot of topics. 0 is a good number. So just because we plug in 0 doesn't mean it's you can just ignore it. It's actually part of the point. Way it works though is now that we have those 2 points, I can go 6 along the x-axis. That's my 6, 0. I go 3 along the y-axis. That's my 0, 3. Connect the dots. Oop. All right, let's do this solve for mx plus b. So we want to try to get y by itself. That's our goal. Get y by itself. Isolate y. So I'll start off by subtracting 3x from both sides. I get 6y equals negative 3x plus 18. And then I want to get y by itself. I got to divide by 6. So I divide each thing by 6. Negative 3 over 6 is negative 1/2. And 18 divided by 6 is 3. So this here is my m. That's my rise over my run. And this, if I put it after 0, gives me a coordinate. It's the y-intercept. 0, 3 is where it crosses the y-axis. And which crossing it means we're intercepting it. So we call it the y-intercept. And now I'm going to use the negative 1/2. I can do negative 1 over 2. Or I could do 1 over negative 2. Negative 1 over 2 means I got to rise negative 1, which means go down 1 and go right 2. And I can do that a few times. Or if I do 1 negative 2, it means go up 1 and go left 2. So I could go up 1 and left 2. Assume that I went through the blue dots the whole way. So this is why they say every increase in x by 1, y increases by m. In this case, negative 1/2. So if I'm here and I go right 1, I increase a negative value, which is actually decreasing. I go down 1/2. I'll give you guys one to try. So try doing the following one, both ways, as intercepts and the slope intercept form. Uh, 4x minus 2y equals 8. Try doing that one both ways. Yeah. That was beautiful. All right. Feels like that was long enough. So what'd you guys get? What's the two intercepts? Someone be brave. Nobody? When x equals 0, we have 4 times 0 minus 2y equals 8. So negative 2y equals 8. Divide by negative 2. And I get y equals negative 4. So I get the point 0, negative 4. And if I do y equals 0, I get 4x minus 2 times 0 equals 8. So 4x equals 8. Divide by 4, and I get x equals 2. X equals 2 when y equals 0. That was the criteria. So 2, 0 is right 2, up none. And 0, negative 4 is right 0, down 4. So I'll just connect these two dots. Right? So for the other method, got 4x minus 2y equals 8. I'll start off by, what I'm doing is I'm adding negative 4x to both sides. That might make it a little bit easier to see that since I'm adding them, it doesn't matter which order I put them in. So I put the x one first. Yeah. Subtracting is the same thing as adding the negative. Yeah. That does the same thing. The reason why is because I've been doing, if I do 8 minus 4x, I still write it this way. And it's dawned on me that some students may not realize why I'm adding the 8 to it. Because I'm saying subtract. But the same thing as subtracting is adding the negative. So if I add two numbers, like I add a and b, it's the same thing as adding b plus a. Like 2 plus 3 is the same thing as 3 plus 2. So 8 plus negative 4x is the same thing as negative 4x plus 8.
Yeah, I guess that helps you when you like try, because or else you can make the mistake of putting -2y equals 4x minus 8 or something.
Right, it can help you. It can help you avoid mistakes. It also makes it a little clearer. Like, once you know that you're adding them and you're okay with it, you don't need to. The plus and negative doesn't help you if you already know what you're doing. The only thing that was this, I did that for, it was to illustrate something like this. And why I write x first. If you're already comfortable with adding them, with just by saying minus 4x, stick with that, it's quicker. Now I gotta divide by -2, and I gotta divide everything by -2. Y equals -4 divided by -2 is +2. And 8 divided by -2 is -4. So I have a y-intercept of 0, -4. And my slope is 2, which is the same thing as 2/1. So 0, -4, start off down here. This is my up 2, right 1. So I go up 2 and I go right 1 and I put a point. And I can go up 2 more and right 1 and put another point. I can also treat this if I want to go the other direction. I can put -2 over -1. And this allows me to go down 2 and left 1. And you see it still generates a point on the line. I went the other direction. And the only real reason to do that is to make connecting the dots, making a straight line a little bit easier. Now, most of your graphing is going to be on the computer. So like this is more of it's a math course, so you're supposed to learn some fucking math in here. This is me teaching you some math. That was a lot of good practice there. Sometimes we're not given the equation. Sometimes we're just given 2 points. Sometimes we're given the slope and a point. So if we're given 2 points, let's make the line. I'm going to give you 0, 3, and I'm going to give you, oh, we did this one earlier, 6, 0. So like when I mean make the line, I mean like you can graph it if you want and write the equation. So graphing it is what we've been doing today. Zero, 3 is right there, and 6, 0 is right there. I'm gonna rotate it so I can draw a straight line. All right, there we go. So to make the line, it's helpful to find the slope. The slope is handy. So I can do either point as 2. I'll call this one number 2 and this one number 1. So I have 3/0 minus 0/6. I get 3/-6, which is -1/2. Then you have a couple options to find the equation. You can use y equals mx plus b, or you can do y minus y1 equals m times x minus x1. This one is fantastic. If one of your points is the y-intercept. Otherwise, it's a little bit slower. And more error prone. All right, so let's do it for this one. I'll do it a couple ways here. So the quickest way is we have the y-intercept. The quick way. We have m equals -1/2. And the y-intercept is 0, 3. Which means that right there is my b. And it means I can just plug them directly into y equals mx plus b. And I'm done. That doesn't happen all that often, but the homework might have it on there for you. And that's the quick way. And let's look at like maybe doing it like, let's use 6/0 the same way. Y equals mx plus b. I'm going to use the point 6/0. So my x is 6, my y is 0. M is still -1/2. And I've got b. -1/2 times 6 is -3. If I add 3 to both sides, I get b equals 3. And now plug m and b in. Y equals -1/2 x plus 3. That's if you don't have the y-intercept. That obviously this could be done quicker. I already showed that. The other equation, y minus y1 equals m times x minus x1. I'm gonna say my x1 and my y1 is the 6 and the 0. So I have y minus 0 equals -1/2 times x minus 6. So if I distribute, well, y minus 0 is the same thing as y. Then I have to distribute here. -1/2 times x is -1/2 x. And then I have -1/2 times -6. And -1/2 times -6 is +3. And you'll see we got the same thing on all of them. The pros of this one right here is that I didn't need to remember once I had B to plug it back in. Like here, once I plugged it in, I just clean it up and I'm done. Voila. And we'll call that a wrap for today.